Hey everybody, this is Larry. This is me going Q4 of the weekly contest 483 minimum cost to merge sorted list. Hit the like button and subscribe and join me in Discord. Let me know what you think about this one. Honestly, the first thing that I did was look at the constraints, and I saw the constraint is equal to 12. I immediately knew what I wanted to do. I mean, at least overarchingly. On the details, it still took me a little bit of time, but I knew what I wanted to do, which is this 3 to the n idea. I'm not going to go over the proof really deeply because it's kind of a little bit tricky. But what is the 3 to the n idea, right? First of all, it's going to be based on bit mask. So definitely you have to know bit mask dynamic programming, right? I mean, I'm not going to sugarcoat it. This is a hard Q4. If you don't know bit mask dynamic programming, it is a prerequisite for this problem. You just need to know it. And it's not too hard. You just have to kind of practice a little bit. Because the bit mask part of the bit mask dynamic programming is just using it as a Boolean list for some set of items, right? But in terms of the 3 to the n trick, I actually forgot the name of this. Let me know in the comments, and as I find it out. I always forget what it's called because I just kind of I just always known it ternary assignment, yeah, maybe, but I don't know, but it's called the subset. Maybe I call it the subset trick, but the idea is that okay, so let's just say you have a bit mask, right, and I'm gonna write it in binary, right? And this depends on all the two ways you can think about it, right? The way that we for this particular problem, we want to construct it such that, at least for me, the way that I did it is that, okay, well, this means the best cost to get this bit mask, right? And this bit mask means that list 1 is used, list 2 is not used, list 3 is used, list 4 is used, list 5 is used, list 6 is not used, and so forth, right? So you can think about it as like a true, false, true, 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 false, true, right? So that's the bit mask portion of it. And then the formulation for the DP would have been that, okay, well, we want basically two pieces, maybe say a left piece and a right piece, almost like a divide and conquer, right? Maybe it is divide and conquer, even, you could say. So you want two lists that merge together, construct this list, right? So one example, for example, could be you could have 1 0 0 0 0 0 1, right? And then that means that to be this bit max directly, it has to be 0 0 1 1 1 0 0, right? So that's kind of the core part of the idea, and the bit mask portion of this just makes it easy to do this check in very fast time, but also that you could actually do this with one operation, right? Well, one bitwise operation, which there's a lot of nuance about if it's constant or whatever, but for now we'll just ignore that, right? But yeah, and then you kind of try for all of them, right, to see the best one, and there's some cost which is defined in the problem statement, right? But for example, you go to then now that means that this one has to have this one so that it has it in the result, right, and not both times. So that's basically all we're trying to do. The quote unquote, so the naive way that you may do if you haven't done stuff like this before, right, is that, okay, well, at least for me, is that as we said, R is actually can be calculated from, well, your input and L, right? I mean, that's basically what I did. For example, I look at this and I go, well, what does the R need? And then I just wrote it down, right? So okay, so that's the thing that I want to point out. So what is kind of like maybe like a naive way of writing this would be that, okay, well, now we try 1 0. So this is, I'm just rewriting it, right? So this is the bit mask, right? So then for L, maybe we try just very basic. right? I don't know if I'm off by 1. And then now we calculate R is equal to the rest that we didn't do, right? And then now maybe we try another one. We go do 1 0, and you can think about this as a binary number still, right? So maybe try this next, and then this, right? Dot dot dot. And of course that's going to be fine, right? Except for in the second line. I'll change the color. In the second line, well, this is impossible because, well, you have a 1 here, and if you have 1 here, then you cannot construct the 1. I mean, yeah, because you have an extra 1, right? Yeah, that means that you're using a list that you don't want to use. Okay, I mean that's fine, right? We can just do an if statement, do some operations, and be like, okay, we should not check this. However, the problem isn't the checking it. The problem is that now, as a result, well, how many bit masks are there total, right? That we want to solve for? Well, there's just 2 to the n, right? Hopefully this makes sense. I don't have to go over it too much. But for here, also the way that we wrote it is also going to be 2 to the n, right? Because we try 1, 10, 11, 100, so forth, dot, dot, dot. So now you have 2 to the n inputs. Each of them, you do a loop of 2 to the n. That is just going to come out to 4 to the n. Which for this one, I don't know. Maybe, given that n is equal to 12, is equal to 2 to the 24. Which is going to be a little bit slow. I mean, it may be fast enough for certain languages, whatever, so like, don't hold me to it. But for me, in Python and just thinking about it, it's going to be too slow. But there is this idea called 3 to the n trick that I'm finding, that I've been teasing maybe, that I'm going to mention, is that, well, we know that, we know that like some of these are not possible. So can we just skip them? And the short answer is yes. And it's this trick that you can kind of figure out by, well, actually, I don't know if you can figure it out, but you can do a sort of a proof just by visualization and practicing by playing around with it. But yeah, the idea. Did I wait a while? But yeah, the idea is just to start at, start L at the B, though in this case you may skip it because it just means that R is equal to 0, which means that you're not merging anything, which is not interesting, right? But the next one is that now you just subtract 1. So this is the same as what we would have done, but then now you do an AND statement on the init from here, a bitwise AND, to the bit mask, because then now any digit that got changed would have changed back, right? And that's basically the idea. And yeah, and then the next one, if you subtract 1 again, you may get do, but then now you have this 0, so then this is now 0 again, right? And then now the next one's gonna be 0, which is, I think this one doesn't change anything, right? I don't know what, oh yeah, and then now but that's basically the idea. And it turns out that if you do it this way, and the math is actually a little bit trickier, I urge you to kind of Google and look it up for the proof. But it's just that the sum of all these, right, the number of inputs plus per input or times per input, the sum of all that amortized, it's going to be 3 to the n. And 3 to the n, it is just much faster. That's basically it, right? For example, 4 to the 12. Actually, let me just plug it in real quick on the calculator, right? 4 to the 12 is 16 million. 3 to the 12 is 500,000, right? So that's kind of the core idea behind this idea. And then once you know that, once you figure that out, everything else is just straightforward and matching it. I mean, you should verify it with the constraints, but they made the constraints such that that is basically the solution. So yeah, because yeah, there's like some definition about the length and the median. I guess the median is a little bit tricky actually if you don't really think about it. But keep the key thing to note is that given 12 lists, there are only 2 to the 12 power lists, right? Meaning that there are only 2 to the 12 possible lists merged together. And so if you do that, 2 to the 12 is like 4,000. So you have 4,000 lists. Each of them may be up to 2,000, but not all of them, and most of them do not. So you can amortize that out, and then just calculate the median. And that's basically what I did. This is the pre-processing, right? So I contain the median and the lengths for pre-processing, and then this is for every possible bit mask. I created a sorted list. You probably don't, actually, now that I think about it, maybe I didn't need it. Maybe this is why this is a little bit on the slower side. Let me actually do. Oops. So I don't think this matters too much. Yeah. Let's see. I mean, I think it's still. Oh, I probably should have ran it first. Post and list. Oh, this is extend. That's why. May still time out, but that should be a little bit faster now that I think about it. But yeah. Oh, actually, that was enough to make it AC. So maybe that was my fault. Huh. I didn't really think about it enough. Guess that makes sense. Oh well. Yeah, okay, so that is my fault. But yeah, so this is the pre-processing. You just kind of have a list of all the elements in that list given the bit mask, and then you sort them. You calculate the median, and the median is easy to calculate from that. And then you have the lengths, and you're good, right? And then now, I don't know if this is a good base case. I guess you can maybe even further write this. I thought about this during the contest. I mentioned it, but right, something like that. Is this slower? Oh no. Don't know. Alright, we'll just keep it like this for now. I don't know why it's having issues. But yeah, so I just have base case because I was too lazy to write out incorrectly how to do it, I guess. I don't know. But yeah, and this is the 3n trick I told you about. You just take the bit mask, and I still have a bit mask -1, though I guess technically it should be bit mask -1 and bit mask. I think that's probably the next one. So that's maybe imprecise as well, actually. But yeah. Yeah, after you calculated everything, then now you have B. We just kind of go do the 3 to the n trick one at a time. We get C, the complementary, right? Because this is the current set of everything. We have B, so then this is the equivalent to what I said left and right? And then after that, it's just doing the maps, right? So you have the best, the recursion on B, the recursion on C, lengths of B, lengths of C, which is in the problem statement, and then yeah, the absolute value of the medians, or the absolute value of the delta of the medians, right? Also what they tell you, and that's it. This is other than this loop setup, it is a pretty straightforward DP. I mean, you do have to pre-process, but yeah. What's the complexity, right? As I said, this is 3 to the n. No, I mean, yeah, 3 to the n, because everything else is pre-calculated anyway. Times 2 to the n times n. Yeah. Maybe a little bit more due to times log n or something. But yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And you can watch me solve it live during the contest next. Let me make this slightly smaller. Still doesn't really fit everything. Well. Almost everything. That's good enough for me. Right, and that's it. Thanks for watching, and yeah, you can watch me solve it live in the contest next. It's very tricky case enumeration, and I probably could have written this in a way that is easier to debug. Instead, I wrote it in a way that if I had been wrong, it would be impossible to debug. But okay, let's Q4, let's go. How much time? 2 hours? That's not right. Why is this a long contest? Did I do something weird? Okay, well, I don't know what happened there. I don't know what's going on, but let's just solve it before 2 hours anyway. There's only 12 lists, so this is just bitmask DP, right? Funny that we almost kind of did that on Q2 anyway. Is it bitmask DP? Or is it I mean, it is there is bitmask, but it's actually it's actually whatchamacallit, like you have to do like the 3 to the n trick. How do I write it exactly? I mean, I was gonna write it top down, but I guess probably yeah, probably need to do it another thing. Was it called sum over subset or something, right? Okay, I mean we have to pre-calculate the median, so then yeah. And then I have to figure out how to merge, but not merge, but I had to figure out how to do the DP exactly. I forgot, but that part's fine, maybe. It should be fast enough, but maybe not. I don't know. I guess we'll see. I thought I could use extend. What is SL update? Hopefully that works. This by definition should be good, right? Why is this wrong? Oh, because it can be 0. I don't know. Let's do that for now. Oh. Oh, I did it the other way. Whoops. Is this right? Probably probably, right? But also need, let's just say, oh, this one I probably don't need to pre-calculate, but yeah, it's fine. Okay, so we need it for that, and then it is just I'm trying to do it not 4 to the n. I'm trying to think what's the easiest way to do it. Oh, of course. It is just subset, right? And then it is the complementary of that subset. So okay, that makes sense actually. Yeah, okay. What am I doing? Okay, so you take the left and you take the right, and then what? You get the cost. Oh, I say no. This doesn't make sense. I mean, it's fine, but we need at least one of the list, right? That's not the base case. That's fine. Yeah. Okay. Is that it? Right. What am I doing? Maybe that's it. Cost of, yeah, okay, yeah, because this is the total cost of whatever. Okay. Yeah. I don't know why I'm writing it this way actually. You could probably just check the bit count, but I didn't want to keep checking the bit count. I don't know that this is faster than just checking the bit count though, so maybe I'm wrong on this one. Okay, and then now yeah, because it can't do itself. Is it n-1? Wait, how is it? No, that's right. Excuse me. Probably dying. It's okay. If this is the problem that kills me, it's probably fine. Infinite. What am I doing again? I have infinity and beyond. Oh yeah, that's right. I want an F-min. I mean, that's it, right? So then now, F, so best is equal to F min, best F of B plus F of, it's technically F of, No, that's right. Okay, yeah, no, that's right. Yeah, no, that's right. I always try to think about what to do with the zeros, but I guess it doesn't do anything because it doesn't get flipped. So it's this plus the cost, which is length of B. Oh, let's just go with C0. I don't know why I call it C, I forgot. B plus length of C plus absolute value of medians of B minus medians of C, and we are Gucci, I think, right? Something like that. Ooh, so close. We got this one wrong. Why? I mean, it's good because this is an easy one to debug. Or it ought to be. Okay, so medians are, ooh, 7, that's probably why. No, 7 is the order numbers. Maybe 0, 1, 2, no. Both is, no, the 7 is wrong. Why is this wrong? So this number is 4. Oh, okay. I mean, that's easy fix. For 4, you want 1. For 5, you want 2. So this should work, right? For the index. Alright, so that looks okay. Yeah, we're going to change it slightly. Why not? It's an extra 20 seconds should be fine. Hopefully no silly mistakes. I mean, I won't even mention, I guess typos and time limit exceeded because I did it top down instead. Maybe I should have done bottoms up because Leetcode things. And we're almost done. I hate that Leetcode just makes you write like very unnaturally, at least in Python. And I'm lazy today. I'm not. I mean, I could rewrite this, and maybe I should I should have written this to begin with the other way, but I don't know. It is what it is. We'll just ask ChatGPT to convert my code for me. Hang on. If I could find my ChatGPT window. Do I have a chat? Oh no, there it is. We'll see if it works. And if it doesn't work, I still just blame Leetcode, but yeah. Yeah, I mean, again, is another classic Python Java thing. Oh, I mean, I think someone told me that there was an issue with this contest though. Well, I think only in the US, so maybe in China would have been so it's like accurate in China maybe, I don't know. So 17 was pretty nice though in that context. And keep in mind that I ate a 5-minute penalty, so I would have been faster maybe. Not by that much. I mean like 13. 17 or 13 is fine too. But yeah. We'll do a retro real quick. Let me take a mental break. Yeah, let's do a retro. I don't remember any. I mean, I guess I should remember Q3, right? Am I? How? Oh yeah, this one. Yeah, that's right. I mean, that's fine. I because I forgot what it was. Honestly. Yeah, so Q1, I mean, yeah, the thing is that with larger numbers, right? With numbers that are larger or whatever, the longer the string or the longer the number, unless you have leading zeros for some reason, it's always going to be the longer is the bigger number, right? Like if you have 1,000, it doesn't matter you have 999. The nines are big, but 1,000 is still more, right? So by that idea, you don't really want to remove anything really, but you have to make it an even number. So that's basically the logic I have for this, right? Oh, I forgot that I'm not explaining yet. So, well, I mean, I could explain, but it's just a retro. But one was fine. Q2, we have 15 numbers. I mean, it's just about doing 15 times 14 times 13 times 12 times 4, maybe if you want to say, for the number of characters. After that, it's just you see that the numbers are so small that it's just, yeah, brute force. It took me a little bit of time though. This one, I mean, this one is just about enumeration in terms of the number of cases, and then just think through whether there are more possibilities. I don't really have any trick for this one other than think harder, I suppose, for me. Note to myself, just to be clear, not for anyone else. And Q4 was pretty straightforward. I mean, I almost was going to say, yeah, like my Q3 and Q4 time is mostly the same. So, yeah, and some of that, I don't know. Well, I just was a little bit slower on Q4 because I figure I got it anyway. Thanks for watching, everybody. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.